We've really reached the end of the cardiac. There's only a few slides here that I want to show you, and then we'll be done. It's quite quick. So this is a review of the cardiac output because it's really important, where we talked about heart rate times stroke volume, right? That's going to give you cardiac output. So try and not confuse stroke volume and cardiac output. Stroke, remember, is per stroke per side. Cardiac output is really the total volume that we're interested in, which is in milliliters per minute. Some things to remember. So average heart rate is about 60 to 70, and during exercise it can go up to 145 or even higher. You've probably measured that during your own exercise. The average stroke volume is about 70 mLs, and that can go up to about 200 during exercise. So that's quite a change. I could have you calculate some of these on a quiz. So these are good little math problems. The average cardiac output then at rest is about a liter, right? 4,900 milliliters or 4.9 liters. And during exercise can go up to something like 29 liters, which is a whole lot more. So you're moving a whole lot more blood trying to oxygenate your tissues during exercise. When is this cardiac output? You know, we're so interested in what is the cardiac output. Is it being efficient? Is the heart working well? When is it altered? What are some examples of that? So I've written for you as a general rule a patient with a heart rate that's too fast. So if heart rate is go, 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 too fast, more than 150 beats per minute, it's not enough filling time, right? If it's going to abdub too quickly, then it's not going to have enough time to fill during diastole. Let's look at the alternative. What about too slow? Less than 50 per minute is not going to be enough oxygen distribution rate. So in this case, it's even more dangerous, where that cardiac output is so low that not enough of it is getting to the tissues to be able to oxygenate those tissues. So not too fast, not too slow. That's what's going to matter here with heart rate, when that heart rate can change so much. So as a review of Frank Starling law of the heart, this might not be a review. Let me go back to that. The Frank Starling law of the heart says that the stroke volume must match the venous return. So let's think about that. What's venous return? It's how much is coming back through the venous system, like through superior vena cava, right? So if you're going to pump a lot, that's your stroke volume, it must match the amount that's coming back to get pumped again. If not, you're going to have backup somewhere, correct? You have to, what you're ejecting has to return, and then you eject and it has to return again. So as a definition I put there for you, venous return is the amount of blood that fills the right atrium. So an increased venous return increases the end diastolic volume. So let's think about that a little bit more. If you have increased venous return, all of a sudden you have more blood coming. And why would that be? Well, let's say you've just started to go out and run around the block, and you're going to go for a run, and you just started running. All of a sudden you get this surge of more blood coming back because you're going to have to catch up and distribute more of that. So you have increased venous return, and it's going to increase the end diastolic volume, right? Because if you have more coming in at the end of diastole, you're going to have a greater volume of that blood coming in to both the atria and the ventricle. Does that make sense? So increased venous return is going to increase the volume that the heart has to all of a sudden handle. So what happens there, and this is the Frank Starling law, is that it has to adapt. It can't just pump with the same force it was pumping before when it had a lower volume of blood. So what Frank Starling figured out is if venous return increases, then the heart is going to pump more forcefully. Part of it is stretch, right? It's going to stretch that ventricle quite a bit. And then that contraction of those, actin and myosin sliding over each other is going to be more forceful because they've been stretched out more. So that's what that law is. If venous return increases, then pump more forcefully because you have more blood coming in and you need to distribute that blood. Okay, and that's where we're going to stop. And you got it all now. It's all there. Everything you needed to know about the heart. Thanks, guys. Bye.